Hello, class. We're skipping section 5 for now, and then we are going to jump to section 6 first. We want to do all the numerical math first before we get into the word problems in section 5. Today we're going to do linear inequalities. So if you remember things like y is greater than mx plus b or anything like that. And then you have to do the shading and the dotted line and the solid line. And so that's going to kind of come into play today. Now I'm going to kind of change it up a little bit because I'm going to give you just the first page of the notes, and then tomorrow in class as we recap I'm going to give you guys the second page of the notes, and then we can work on the homework, okay? Just because this is just because a lot of people some people prefer the video, some people prefer teaching up front, and so I'm kind of doing both. A system of linear inequalities is a set of two or more linear inequalities in the same variables. The solution is lots of solutions, and it's going to be all the shaded parts. So if we look at example 1, this is the first part, checking solutions. The directions say tell whether each ordered pair is a solution of the system. So we have inequality line A and line B. Y is less than 2x, y is greater than or equal to x plus 1. So for part A of this example, they're asking, does it work? And so all we have to do is take the two separate equations. So if I have line A, maybe I'll do line B in red so that we are not confused. So if I do line A in blue, and 3, 5 is my x and y, I'm just going to replace that with 5 less than 2 times 3. And so I have 5 is less than 6. Okay, so for line A, this works. For line B, I'm pretty much taking the same coordinate, and instead of line A, I'm going to do line B and do the same thing. 5 is greater than or equal to 3 plus 1. 5 is greater than or equal to 4, and that is also a true statement. Therefore, this does work. Yes, it's a solution. It's a solution. So why don't you pause for a sec and just try letter B, and then you can unpause just to check your answers. So if you got line B that works, 0 is greater than or equal to -1, that works. But for A, 0 was less than -4, but that doesn't work. So since it doesn't work for both inequalities, it is not a solution. So that's kind of the first part of what your homework will be. Why don't we scroll down a little bit and start getting to the graphing. Take a few minutes and pause for a sec. The key idea here is we're solving by graphing, so read through the procedures 1, 2, 3, and 4, and then we'll just jump straight into examples 2A and B. Okay, so according to the steps, number 1, we got to make sure that each inequality, linear inequality, is in slope-intercept form. So if we look at line A and line B, we notice that they are in slope-intercept form, so that's pretty good. Again, slope-intercept form is y equals mx plus b, in case you forgot that. And then we literally just have to do the same rules that we did in chapter 5, right? If there's an equal sign, there's a solid line. If it's if there's no equal sign, then it's a dotted line. If y is greater than, then it's shaded above, and if y is less than, then it's shaded below. So for A, y is less than or equal to 3. There's no x value. So this is actually a horizontal line. This is going to be a horizontal line at 3 on the y-axis. So in blue, and it's going to be a solid line since I have an equal sign. So there's my solid line, and y is less than the 3. So you know, if you don't have markers or anything, that's fine. So what you can do is for line A, I'm gonna shade things up and down. and then for line B, I'm going to shade things left and right. Okay, so for line B, we have y is greater than x plus 2. My y-intercept is 2, so I'm going to put a y-intercept at 2. My slope is 1 over 1, so I'm going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And since there is no equal sign, there's going to be a dotted line. Dotted line. Dotted line, and y is greater than x plus 2, and so I'm going to shade it going left and right so that when you see where they intersect is this purple shaded region right here and onward. That is a mixture of our solutions. There are lots of solutions in there, lots of coordinate points that work. For example, if I pick this point right here, it's hard to see now because I have so many lines. It's negative 1, 2, 3, 4. Negative 4, comma 1 is a possible solution for both A and for B. So you could go ahead and test that. So that's kind of it. We're just seeing where the shadings overlap. So why don't you pause, try letter B on your own, and then you're going to check your answers, and then tomorrow when you come to class, I'm going to give you the back page of the notes, and we're going to work on that in class together. So pause for a bit, try line A and line B for example 2A. So actually, if you noticed for example 2B, now if you notice that they were parallel lines, you may have thought, oh, I know there's not going to be a solution right away, but you got to be careful because a solution in inequalities is anytime the shadings overlap. So even though the lines are parallel, it's possible that they could be shaded in between the parallel lines. However, these two parallel lines, the shadings are on the other sides of each other, so they will never overlap. Therefore, my final conclusion is that there is no solution. This is actually considered an inconsistent system. An inconsistent system. Inconsistent system. So that's just the first page of the notes. Tomorrow I'm going to get to the second page, and I will pass that out separately so that some of you kind of benefit from the teacher-student live interaction.